This class discusses mean and standard deviation of a discrete random variable. The mean of a discrete random variable is denoted by μx, or simply mu. It is defined by the sum of products of x and its corresponding probability. Sometimes mean is also called expected value or expectation. For example, let x be the number of heads when tossing a balanced coin 3 times. The table lists the probability distribution of x. To calculate its mean, we use 0 times 0.125 plus 1 times 0.375 plus 2 times 0.375 plus 3 times 0.125. See, we calculate the product of x and its probability for each possible value of x, and then add them together. The mean of x is 1.5. Notice that x is the number of heads. Its mean is 1.5. The possible value of x is 0, 1, 2, 3, and is an integer. However, the mean of x is a decimal. The number of heads cannot be 1.5. How to understand that the mean of x is 1.5? The probability should be understood as the proportion when the experiment is repeated many times. The mean of a random variable should also be interpreted in a long-run repetition. It is the average of observations. For example, repeat the experiment of tossing the balanced coin 1,000 times. Notice that one experiment is to toss the coin 3 times. Repeat the experiment 1,000 times, and we essentially toss the coin 3,000 times in total. The table lists the frequencies of the number of heads out of the 1,000 experiments. We have 0 heads for 136 times, 1 head for 377 times, 2 heads for 368 times, and 3 heads for 119 times. The average number of heads is thus the total number of heads divided by 1,000, or 0 times 136 plus 1 times 377 plus 2 times 368 plus 3 times 119, and then divided by 1,000. The average is 1.589, so this sample average is close to 1.5. Recall that the sample mean is an approximation to the mean of a random variable. If we increase 1,000 experiments to 10,000 experiments, the sample mean will be even closer to the mean of x, 1.5. The standard deviation of a discrete random variable x is denoted by sigma x, or simply sigma. Usually, we first calculate the variance, sigma square of x. The standard deviation is the square root of the variance. By definition, the variance is the sum of the products of squared deviations from mean and the corresponding probability. Sometimes we may first calculate the sum of products of squared x and its probability. Let's explain these two formulas in terms of an example. Let x be the number of heads when tossing a balanced coin 3 times. We have already calculated that the mean of x is 1.5. Using the first formula to calculate the variance, we need to first calculate deviation from the mean for each possible value of x. Notice that x has 4 possible values. The deviation from the mean is x subtract mu, or negative 1.5, negative 0.5, 0.5, and 1.5. We square each deviation and multiply them by the corresponding probability and add together. The answer is the variance 0.75. Using the second formula to calculate the variance, we square each possible value of x, multiply them by the corresponding probability, and add together. Make sure to subtract mu square. The result is also 0.75. The standard deviation is square root of 0.75, or 0.866.